Hey, what's up everybody? This is Papa Bale and welcome to the channel. What we're looking at here is a rotor that was spinning at 25 volts through the drive circuit. We've now shut the power off and we're going to see how long it'll spin for, considering I have the flyback diodes hooked up with capacitors for each one. They're only 10 volt capacitors though. But the way I figure it, every time the switch hits, the circuit closes, which allows energy to go into the capacitor and at the same time come out. What comes out is a little bit less than what goes in every time because of heat loss. So yeah, we're just timing how long this will spin for. What we're actually measuring is the decreased rate in deacceleration. So it's deaccelerating slower than it would if the diodes weren't hooked up, if you follow me. In the beginning, if you notice, the machine, well, I don't know if I got that on there, but it started by itself. All I had to do was turn the knob on the power supply and it started spinning. I have to believe that in part was from the recycled energy. So what we are going to do, just for fun, I'm going to move that out to the fringe. So the full duration of the video, the power's been off, so 2 minutes and 30 seconds coming up on. Now if I pull the reed switch all the way back, the circuit remains open, and I don't believe any of this magic happens when the circuit is open. And it'll get down to around the speed to 10 volts, and then it'll stay there for a while, and then it'll drop below that because every time it recycles it gets less and less. But with all the stuff that's going on with this thing, like the weight, wow. Okay, so it's spinning counterclockwise and it looks like it's spinning clockwise. That's awesome. Still going that fast. You know what? I'm going to use my my laser over here. $14.48 divided by 12, I guess. And we're down to 772.3. This is RPMs I'm mentioning. $12.64. Huh. Maybe I'm doing this wrong. I always wondered if I was doing that wrong. All right, we are It looks like we're still going pretty fast. Five minutes in. I wonder if like we hook up these bigger capacitors, if that'll help. Because it's not in the drive circuit, I think it'll be alright. I mean, it's not directly in the drive circuit. Because you put a 100 volt capacitor directly in the drive circuit, and then the power supply is only 25 volts. You got an issue right there. But these starter capacitors over here, start capacitors, we're gonna try them. 6 minutes and 30 seconds, people. Quite literally, all we're doing here is watching this thing spin until it stops. And I'm trying to fill in with some commentary. Because the circuit has to be closed in order for the electricity to flow through it. Now, I don't know if the flyback circuit actually is part of the drive circuit. I'm not entirely sure. I think it's a separate circuit. Because the way I set up the diodes in between the coils, I think it will function as a separate circuit as well. $732. Kind of want to unhook the diodes and see if we can get it to spin for however long this is going to spin for without them. Nah, I'm not really interested in that anymore. I might hook up the big capacitors though. 8 minutes. So neat. So cool. So it's not hitting every time every magnet pass now. It's hitting like every fourth one. It's only hitting like 3 times the rotation. The slower it gets, the fewer times the reed switch will hit too. 9 minutes. We're up at 9 minutes now. So it's been about 10 minutes. That thing will spin for. Well, I ran it on 25 volts for about 30 seconds actually. Got it to get up pretty fast. It never completed its acceleration though. 9 minutes and 30 seconds. So only 3 hit. 1, 2, 3. $10 minutes. And that was my original assumption, that it would spin for 10 minutes. And that's awesome. Thank you very much, people. Have a good day. Please subscribe. Bye now.